Hello, algebra students. Welcome to our very last day of geometric sequences. Now, as a little reminder to you, a geometric sequence is a sequence. For example, how about we try 2, 4, 8, 16, and a geometric sequence is when you multiply by the same number every single time. And it actually goes up really fast. It's not linear. It's not going to create a straight line as a graph. Your graph would look like this, and it goes up very, 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 very fast. So that's our little tiny reminder of what a geometric sequence is, because our essential question today is, can I use geometric sequences? And so at this point, we are going to say, okay, you know what a geometric sequence is. We're going to practice writing the function. So we're going to take the whole sequence and write it as the little equation. And then we're going to do one more thing with it. And I'm hoping that this is like, okay, we finally found out a reason while we're doing this. And it actually is not going to add a whole bunch of work. It's just one little tiny step after that. So the easiest way to do that is just to dive into an example. We might spend a little bit more time on this first example or a little bit more room, but the following examples you won't need as much space. So I'm going to write a sequence. I'm not going to write the function. I'm going to write the sequence here. 12, 48, 192, 768. Okay, that's going up real fast. We started with 12 and only 3 steps later, we're at 768, which is why the graph looks like it goes up really, really fast. It doesn't look like a straight line. So, a reminder of what your function is going to look like, because at this point, my hope is that you can jump from here to here. If you're ever on a test when you get to Algebra 2, like all of these times, this function will be given to you. You just need to know what to plug in where. And so, let's do some deep diving. This right here is your common ratio, and I'm hoping everything I'm saying right now is review. It's our common ratio, what's being multiplied every single time. You can divide, you can do 48 divided by 12, or you can just type it in on your calculator. I know a lot of people do this, 12 times 2. No, that's not right, 12 times 4. Oh, yep, it's multiplied by 4. And you want to check that that's true for all of these. In this case it is. I'm just going to check it for us. Ooh, it's like super wonky, sorry. Okay, so at this case, I know that it's 4. And we are missing this number out here, and I'm going to write it really lightly in pencil because it's our 0 term. It's the invisible term out in front. I'm using a different color intentionally. This is my first term, my second term, my third term, my fourth term, because that's going to come in handy later. This is my 0 term. And what is your 0 term that's invisible and out in front? And in this case, it is 3, because 3 times 4 is 12. So 3 goes there. And you have your function, and you're all done. You're all done in terms of writing the function, but there's one more thing I could ask you, and this is what I'm going to ask you. What is the 8th term? If this is the first term, and this is the second term, and this is the third term, and that's the fourth term, okay, well, I could take the fourth term, multiply by 4 to get the 5th term, multiply by 4, 6th term, multiply by 4, 7th term, multiply by 4, 8th term. I could do that, but what if I asked you for like the 100th term? You wouldn't want to do this like 100 times, right? Oh, I already screwed up. So you wouldn't want to do that so many times. You want to be able to look at this function and easily find out what the 8th term is. And that is why we need to be able to go from a sequence to the function, because I can use that function to find the 8th term. How I do that is, instead of an x, I'm just going to plug in an 8. Do you see where there's an x? Because in my first term, if I plug in a 1, guess what I'm going to get? Oops. I'm going to get 12. If I plug in a 2, I better get my second term. Hey, if I plug in a 3, I better get my third term. So if I want my 8th term, I'm just going to plug in an 8. And it's, whoa, that's a big number. Not as big as they can go. 196,608. Now I don't want to do that by multiplying by 4, multiplying by 4. So it's easier for us to write the function and then find out what the 8th term might be. So I'm going to do a few more examples with you, maybe a little bit quicker. Now is the time to pause the video, finish that, make sure you're understanding it, and then we'll move on to the second one. How about this? 15, 75, 375, ... keeps going. So firstly, I'm going to ask you, what is the 10th term? I already know this is going to be a really big number. Okay, so I want to know what the 10th term is. Now, could I figure out what's being multiplied and multiply it like 10 times? I could, but I think it's easier to write up the function. Especially you want to know this because I could ask you for the 100th term, and you don't want to multiply by. You want to write the function first. So let's look at our function. Multiplied by what? 15 multiplied by 2. Nope, 15 multiplied by 4 is 60. So multiply by 5 every single time. And so our function over here is 5 to the power of x. And then we want to know the invisible 0 term over here. What is our invisible 0 term? What multiplied by 5 is going to give me 15? 2 times 5 is 10. 3 times 5 is 15. So it's 3. I'm going to write a 3 out here in this pen. So I have my function. I want to know what the 10th term is. You just plug it in. And I want to remind you how this is working. First term, second term, third term. Let's just kind of like take a little break here. 3 to the power, or 3 times 5 to the power of 3. Hey, that better give me my third term. You need to be able to see that there's a pattern there. 3 times 5 to the second term. Oh, yep, that's 75. So if I'm looking for the 10th term, I'm going to plug in 10. Holy moly, that's a big number. I'm going to just put these little commas in there for us to read it better. 29,296,875. So I'm going to write that out. Oops, different pen. So f of 10 is when you plug in 10 for x. Do you see how whatever we plug in there, we have to plug in there, right? 10, 10. So at this case, 29,296,875. That's a big number. Not as big as it could go. Could ask you for the 100th term, and your calculator would just geek out on you and be like, it's like, it would have to give it to you in scientific notation because it'd be so big. Okay, one more example. Let's try this one. 18, 36, 72, 144. Let's write the equation. Firstly, what am I multiplying by every single time? How did I get from 18 to 36? How did I get from 36 to 72? What's happening there? And in this case, we're multiplying by 2. I just want to triple check. Yep, you want to make sure to check all of them. So that's a 2. And then I'm going to ask you, what is my 0 term? Let's go backwards. So what's that number out in front? What multiplied by 2 gives you 18? Oops, that's super wrong. Nice, I wrote in pencil. What multiplied by 2? That is a 9. So 9 is my 0 term there. And just to check, we can use our calculator to say 9 multiplied by 2 to the power of 1. Right? Because this is my 0 term, first term, second term, third term. So if I plug in a 1, I better... Ooh, that was wrong. It actually ended up being just fine, but I'll show you why. Okay, there you go. So I plug in a 1 into my exponent, gives me 18. What if I plugged in a 4? It better give me 144, because otherwise I did it wrong. Yep, so I know my 4th term. So I'm going to ask you, I think this is going to be really big. I haven't done this yet. What is the 12th term? I don't think it's going to be as big as I think, but we'll see. Because it's only being multiplied by 2 every time, which is a lot smaller than if it's being multiplied by 5 every time. So I know that this is going to be a little bit smaller. So I'm just going to use my function, and instead of multiplying by 5 or multiplying by 2, multiply by 2, multiply by 2, I can just plug it in my calculator. To the power of 12, 12th term. Hey, 36,864.